lead 3. So it seems likely that the open is in the stator's first coil. The next step then is to make sure where the open is. You can make sure where the open is by taking a reading between lead 2 and lead 3. The multimeter indicates normal resistance between these two leads. Since this current path would not have a normal resistance if there were an open between lead 2 and lead 3, the open must be in the first coil. Now, in a delta wound motor, you always get continuity, that is, an uninterrupted connection between any two leads, even if there's an open in one of the coils. Now let's see how a delta-connected motor can be tested for an open with a multimeter. After the leads are marked to identify them, in this case with colored tape, the multimeter is connected to lead 1 and lead 2, and a reading is taken. The reading is written down for later reference. Next, a reading is taken between lead 1 and lead 3, and again the reading is written down. At this point, it can be seen that there is a big difference between the two readings. The resistance is a lot higher between lead 1 and lead 2 than it is between leads 1 and 3. This means that the open may be in coil 1 or coil 2. A reading is taken between leads 3 and 2 and written down. This reading is about the same as the reading for leads 1 and 3, and it's about half the reading for leads 1 and 2. Therefore, the open is between leads 1 and 2. Now suppose you check a motor's nameplate and it doesn't show what kind of connection the motor has, and you don't have the manufacturer's manual. In this situation, the motor should be tested as if it's delta connected. If the test is made for balanced resistances rather than just for continuity, it is possible to determine the location of an open regardless of the motor type. In any case, when an open is detected, it's usually necessary to rewind the motor. The last stator test we'll look at is for shorts. A short is an accidental current path of low resistance. When a short occurs, a conducting path interferes with one of the normal current paths. The current takes the path of least resistance, which is through the short's interfering conducting path. A short can sometimes be detected by testing for a balance of resistances in the current paths. For example, a partial short in the stator windings can result in a phase imbalance. However, when there is a short in the stator, the imbalance in the current paths may be too minor to register on a multimeter. Since it may be difficult to locate a short, it's a good idea to eliminate the possibility of grounds or opens first. After these possibilities have been eliminated, it's generally safe to assume that the problem is a short. In most cases, when a short exists in the stator of a three-phase motor, the motor has to be rewound. Take a moment now to check your knowledge of how a stator can be tested. This part looks at how two types of rotors can be tested, the wound rotor and the squirrel cage rotor. If a motor has a problem and testing the motor's stator doesn't yield any answers, the next logical step is to test the rotor. The problems to look for in testing a rotor are grounds, opens, and shorts. Let's begin by looking at how a wound rotor can be tested. Let's see how a meg-ohmmeter can be used to test for grounds. The brushes are lifted out of the slip rings to separate the circuit into two parts, the rotor and the external resistances. To test the rotor, the meg-ohmmeter's ground lead is attached to the rotor shaft, and its line lead is held against one of the slip rings. Since the rotor coils of a wound rotor are connected together, the line lead has to touch only one of the slip rings to test all the coils. If no ground is present, the meg-ohmmeter will indicate infinite resistance. If a ground is present in any of the coils, the meg-ohmmeter will register less than normal, or perhaps even 0. If there is a ground in the coils, drying the motor may solve the problem. If it doesn't, the rotor will have to be removed and repaired. Now let's look at how the external resistances can be tested. The meg-ohmmeter's ground lead is attached to ground and the line lead is touched to one of the brushes. If the meg-ohmmeter indicates infinite resistance, no ground exists in the external resistances. If there is a ground, it can be located by following the wiring or by separating the circuit into small parts and testing each part. The next test we'll look at is the test for opens. A multimeter or an ohm meter can be used to test for opens in the rotor circuit of a wound rotor motor. As with the test for grounds, the rotor and the external resistances are tested separately, so the brushes are lifted to separate the circuit into two parts. The slip rings are tested two at a time to measure the resistance through the rotor coils. The first and second slip rings are tested first, and the reading is 12 ohms. Then the first and third slip rings are tested, and the meter reads 12 ohms. And finally, the second and third slip rings, and the reading is 12 ohms. The results of the three readings should be similar. If there's an imbalance in the readings, there may be an open or a short in the rotor. To check the external resistances for opens, the tops of the brushes are tested two at a time. The normal resistance values are usually indicated in the equipment manual or drawings. All three readings should be equal. If there is an imbalance in the readings, there may be an open in the circuit. The next step would be to divide the external resistance circuit into parts and determine exactly where the open is located. The part in which the open occurred could then be repaired or replaced. If a very low reading is obtained during the test for opens in either the rotor or the external resistances, there may be a short in the circuit being tested. Also, if grounds and opens have been eliminated as possible causes of motor trouble, then it's reasonable to suspect a short. When a short is suspected in the rotor coils, the rotor is removed and examined visually. Look for burn marks, which are a sign that a short has occurred. If you don't see any visual signs, the rotor can be placed in a growler to further test it for shorts. A growler is a device that can be used to induce an AC voltage into windings of a rotor or a stator for test purposes. The rotor is placed in the growler and a hacksaw blade or another thin strip of steel is moved around it. If a short is present in the rotor coils, the blade will vibrate. It's important not to touch the rotor's slip rings while the rotor is in the growler, because the voltage could cause a shock. If the rotor is too big to fit into the growler can be held against the side of the rotor. The growler and the hacksaw blade can then be moved around the rotor together to detect a short. Now, you don't have to worry about looking for shorts or grounds in the rotor of a squirrel cage rotor. The rotor bars are already intentionally shorted together by the end rings. And grounds cannot occur because the conducting bars are not insulated from the rotor. Opens, however, can occur. When a rotor bar cracks or separates from its end ring, an open occurs in the current path. A visual inspection of the rotor bars and the end rings may be all that's needed to verify an open in a squirrel cage rotor. Take some time now to check your understanding of how to test rotors. Sometimes it's necessary to disassemble a three-phase AC motor for maintenance or repairs. You may also need to disassemble a motor in order to locate a problem and correct it. We'll look at how a three-phase AC motor can be disconnected and disassembled for maintenance or repair work. The first step in disconnecting a motor is to follow approved procedures for locking out the motor from all potential energy sources. The power leads must not be touched until the power supply has been locked out and the leads grounded. Then the cover to the power leads can be removed and the power leads disconnected from the power source. Power leads are usually wrapped with insulating tape, which must be removed before the leads are unbolted. After the insulating tape is removed, the leads are unbolted. As each lead is unbolted, it's marked to identify it from the other leads. In this example, letters are used to mark it. It's very important for the leads to be marked correctly. If two of the leads are reversed during reassembly, the motor will turn in the wrong direction. And keep in mind that you may not be the one to put the leads back, so make sure that the marking is clear enough for someone else to understand. After the power leads have been disconnected and marked, the motor is disconnected from the equipment it drives. This is usually accomplished by taking apart a coupling. After the motor has been disconnected electrically and mechanically, it can be removed from its foundation and taken to the shop. When a relatively large motor is disassembled, special rigging techniques are usually needed to accomplish the disassembly. But the disassembly procedure is basically the same as it is for a relatively small motor. Now, disassembling either a wound rotor motor or a squirrel cage motor is very similar.